In this tutorial, we're going to review some of Mathematica's simpler features. So let's just open a new notebook. We'll resize it. And we'll start entering commands. As previously, we can define variables. So here's a variable. Let's give it a letter name W, equal sign, and then the braces or curly brackets enclose a list separated by commas. So you'll see that it's highlighted green when you completed the list by closing the curly brackets. And you hit Shift Enter or Shift Return, and it evaluates the cell and returns what you just entered as the list that is known as W. You can comment that out with a semicolon so that when you hit Shift Return, you do not see the output. That's a suppression tool. It can be handy for keeping things tidy. Now we can create a new variable, and we'll define it simply by carrying out a mathematical operation on the previous variable. So Q equals W times 2. And we'll see that the output has changed if you compare the output of W to the output of Q, but then we'll suppress it. And let's create yet a third variable just for practice. Z equals, now in this case I've used parentheses, and that's because we're defining order of operations of the expression that we've created. And you can see that output as well, but we'll comment that out. Now we'll create a new cell, dropping our cursor in a new cell, and we'll create a new variable, and we'll call on the built-in function called thread. WQ equals thread, open brackets, and then of course inside of our brackets we need curly braces to define the contents of the function. And we'll see, oops, I gave it the wrong name. So if you can see that new list contains a bunch of F's. That's because I should have placed a Q there. So when we place Q, now we'll see that we've combined W and Q using the thread command. So we've created a XY list, which is a very powerful tool. There's other ways to do it. We can say, but we can ask what's inside that list by saying WQ double brackets 2. That tells us the second row of the list. You can just play around with accessing the contents of your list if you like. Now let's make another variable, WQA equals, and then this time we'll use the built-in term transpose. We don't need to go into it today, but there's other reasons to use one or the other, but for our purposes today, they're equivalent. But you can go, of course, as you're typing that function, go to the help menu and see what the role of transpose is. Basically, again, in our case, simply combining two elements into a combined list. So open brackets, curly braces, or braces or curly brackets, include the names of the items that you want to include in the new list, and then you can also carry out a mathematical operation on that. So we've transposed W and Q and multiplied it by 2, and now we can see what those values look like, or we can suppress it. We can go immediately to make a plot of those data by using the term list plot. You can notice that it's highlighted until we close the brackets that define what we're listing. So we've made a list plot of the XY plot of the XY data set WQA. Notice that on our x-axis and y-axis that confirms that we're looking at what we expected. So list plot allows us to generate quickly a plot of an XY pair. We can also do a fit. In this case, let's define the fit as a variable. Capital FIT is a Mathematica built-in function that has a bunch of background material that we're not going to worry about. We just want to see generally what the form of the fit expression requires. So capital FIT, open brackets, we give it the data and we give it the expression. Essentially, in this case, x comma x will give us our straight line. And then we can plot the variable. And you can see there that caret tells us that something's missing. Mathematica notices that we've used the syntax incorrectly, so we'll add a comma and fit a plot of a function, which is fit, as opposed to a data set, requires a range of values. So we'll plot the fit over x equals 0 to 50, and you can see that popping up below. So now we've got 2 plots on our worksheet in our notebook. Now we want to show. So the show command allows you to nest plots. So if we open the help menu on that one, we see show several graphics combined. So we're going to show open brackets. We'll go back and draw the list plot again. We could have defined that as a variable and entered the name of the variable there, comma. So first it's going to give us our list plot again, comma. Oh yeah, we can create a variable for the plot if we like. Let's see if that works. Plot, comma, and then again our variable range. Variable range in braces or curly brackets. Oh, doesn't like that. So let's just go back and change that to plot, and then in brackets we'll have to give plot its target, which is, we can make it our new variable. See if I got that syntax right. And that's right. We see a line appear there now. Oh no, still something wrong. Okay, first of all, I'm going to comment out some stuff so we don't have to, so we suppress some of this output and so we don't get confused. So it's going to plot fit. There we go. Now we see that we chose to plot our variable, which was the fit function, and it overlaid that on the same plot as our list plot, and now we can turn to some other stuff. We'll come back to fitting later, but you can also use Mathematica to just plot some expressions that you make up. So let's plot, and we have to use the plot tool for plotting expressions as opposed to data. We'll plot the sine of A. Right, so list plots is for list of data, plot is for functions that we define. So we're going to give it a sine of A, and then with a comma followed by braces, we give it the range of A that we want to plot, and then we make sure we close that off with our braces and brackets. And we'll get a plot, and we can manipulate that plot immediately by manipulating either the function or the range of the expression which we're going to be plotting. We can practice using our parentheses to realize that we can do some mathematical expressions. Oh yeah, but oops, putting those parentheses outside the sine function changes what your function looks like. So let's go back and erase those parentheses and place them instead. Where will I place them? Oh yeah. And see, when you have a mistake in your braces and bracket placement, Mathematica tries to warn you. So now I've divided the whole A times 3 divided by 2 and took the sine of that, and now we're plotting that over some large range. And we're not functionally changing the things very much, but just giving you the idea of the kinds of games you can play.